Hello everyone, welcome back. In this video we're going to take a look how to delete or remove duplicate values from a linked list data structure. Say I have this list of numbers. In my list, number 10 is duplicate. Here number 40 is duplicates. It occurs 2 times. So we want to get rid of all these duplicate values and maintain a list having only distinct or unique values. For that we are going to use set data structure. Basically, set data structure is specifically designed to efficiently store and manage collection of unique elements. The set data structure is represented using HashSet class in C#. HashSet. Basically, it is a collection class that represents set of unique elements. It is part of the .NET framework's system .collection.generic namespace. The HashSet class basically provides high performance set operations like adding elements, removing elements from set, and checking for the presence of the elements. All these operations take big O of 1 or constant time complexity. When we define a reference to HashSet class, we call it set, we get access to methods like add, used to add elements in our set or collection of data. What this add is going to do, it will first check whether this element is present in the set. If it is not present, it is going to add this new element to our set, and this add method returns true. Otherwise, if we try to add the same element again, say I want to add number 1 again, this add is going to check whether number 1 is already present in our set. Yes, it is present, we added previously. Then it will ignore adding number 1 or the occurrence of the same duplicate again. It is going to return false, since one of the properties of set data structure is that it allows only unique values. It doesn't allow duplicate values. We also have another method. Set has another method called contents. It is used basically to check for the presence of an item in our list, in our set collection. Say I want to check whether 1 is present in my list. I can in my set I can use the contents method. Basically, this contents check if 1 is present, it will return true. If it is not present, it is going to return false. So we are going to define a set data structure and keep traversing over the linked list, and each time we add the element to our set. If we are not able to add the element, or if we check if the element is already content in our set, means we have found a duplicate value or a duplicate node, we can easily delete that node. So let me define the set. I keep traversing over the linked list, and each time I traverse, let's say I have a temp pointer here, I will add temp.data, which is this data, each time to my set. So I add number 10 here. Then again I'm going to increment my temp pointer. Temp pointer is going to come here. Again I will add temp.data to my set. Temp.data 20 is added. But before I add each number, I check if my set contains that number. Initially the set is empty. When I add number 10, I check whether 10 is present in the set. No, it is not present. I add it. Then when I reach to 20, I check if 20 is present in my set. No, it is not present. Initially I will add it. Once I come to third node, I will again try to check if 10 is already present in my set. Yes, it is present in my set. So I found a node having duplicate values, so I can easily delete this duplicate value. I obviously maintain another pointer, previous pointer, using this previous pointer and temp pointer. I can easily delete this node. So let's do that, write code for this algorithm. What I'm gonna do, I maintain 2 pointers initially. Let's call it node previous pointer. This previous pointer is going to point to null. Then I will maintain another pointer. Let's call it node temp or current pointer to traverse over the linked list. Initially it's going to point to head pointer, or the first element of the linked list. So initially prev points to null, and head stores memory address 600. It points not head, sorry, temp stores memory address 600. It points to head. And using a while loop, I keep traversing over the linked list and keep adding each element in my set data structure. For that, first I will define a set or a hash set. Then using a while loop, I check while temp not equal to null. I keep traversing. Each time I traverse, I add the data part of each element in my set. So I traverse while temp is not equal to null. Temp stores memory address 600. Temp is not equal to null. So we go to inside the while loop. Inside the while loop, I check first if set dot contains temp dot data. If set already contains this number 10, we found the number or the duplicate node. So here I'm gonna provide a command found a duplicate. We want to delete it. Else, if the item or the data part of each node is not present in the set, we just want to add it to our set. Else we say set dot add temp dot data. We're gonna write this part later on. First, let's add our data in the set data structure. Once we add each data, then we will increment our pointers. First, we will increment the previous pointer, set it to temp pointer, prev equal to temp. Then we will increment our temp pointer, temp equal to temp dot next. This is the else part. So first we check temp while temp not equal to null. No, temp is not equal to null. Temp points to memory address 600. We go inside the while loop. We check if set dot contains temp dot data. If set contains number 10. No, set doesn't contain number 10. Set is empty initially. This condition is false. So we go inside the else block. In the else block, we add the temp dot data and we increment our pointer. So I'm going to add number 10 here. Then initially I will first I will have previous pointer point to temp. So I will have previous pointer point to temp. Then I will increment my temp pointer. Temp pointers come here to the next node. Now temp points to memory address 100. Again, I'm gonna check while temp is not equal to null. No, temp is not equal to null. Condition is true. I go inside the while loop. If set dot contains temp dot data. If set contains number 20. No, it doesn't contain number 20. This condition is false. We go in to the else block. In the else block, we add the temp dot data, which is 20, to our set. Then we increment our pointer. First, I set previous to point to temp. So previous comes here. And I will increment my temp pointer. So now temp pointer points to node having number 10. I'll again check temp while temp not equal to null. No, temp is not null. I go if set dot contains temp dot data. If set contains number 10. Yes, set contains number 10. The condition is true. I go inside this if block. Inside this if block, using the previous pointer, I can easily delete this node. So what I'm gonna do, instead of having this previous pointers, next pointer store memory address 45, I will have it store memory address 900. So I make a connection between the previous node and the node after the target node. This is our target node. So we are going to break this connection and we establish another connection. So instead of memory address 45, we will set previous pointer store memory address 900. Once we store 900, this connection is going to be detached. Next we will increment our only temp pointer. Then this node will not be referenced by any pointer. It will be eligible for garbage collection. To establish this connection, I will have temp previous.next, which is this pointer, point to this node or memory address 900. So I can use previous.next, prev.next equal to where I can get the memory address 900. I can get it from temp.next. So I will set previous.next equal to temp.next, temp.next. This way, this pointer or this reference variable is going to point to memory address 900 instead of 45. So 900 will be stored here, and this connection will be detached. Next, we are going to, after we found a duplicate value, this time we are going to increment only our temp pointer, not the previous pointer. So we just want to increment our temp pointer, temp equal to temp.next. We don't want to touch the previous pointer once we found the duplicate value. So temp will come here. Temp is going to point to this memory location. Now this duplicate node is not referenced by any pointer. It is eligible for garbage collection, and this node will be deleted. So let's delete this node, and we have established a new connection. So right now this previous points to this node or memory address 900. Remember again, once we found a duplicate value and deleted the duplicate node, we don't want to increment our previous pointer because we deleted the node. We just want to increment our temp pointer. So right now our temp is pointing to memory address 900. We again check if while temp is not equal to null, no temp is not null. We check if set.contains temp.data set contains number 40. No, it doesn't. We go to the else block and we add the data and we increment our pointer. So let's add number 40 here. Before incrementing the temp pointer, I will set previous pointer point to temp, then I will increment temp pointer. So previous come here and the temp pointer points to the next node. Temp goes here. Again I will check temp doesn't point to null and set doesn't contain number 50, so I will add number 50 to my list. Then again increment, I go to else block, add number 50 and increment my pointer. So previous is going to point here and temp is going to point to the last node this time, or the tail node temp. Again I will check whether while temp is not equal to null, no temp is not equal to null, temp points to memory address 301. So I go inside the while loop. I check if set.contains temp.data. Yes, set contains number 40. So I go inside the because 40 is already present, I go inside the if statement. Item is found, a duplicate item is found. I want to delete it by setting previous.next, which is this pointer, equal to temp.next, which is this pointer. So previous.next is going to point to null this time. So let's have it this statement, previous.next equal to temp.next. Temp.next is null and previous.next is going to store null. Null here. This connection is going to be detached. If a duplicate value happens to be in the last node also, what we are going to do, since we have maintained a tail pointer, we need to check for a corner case also before deleting or incrementing the temp pointer. We check here if temp equal to tail. This corner case is this corner case if you have maintained a tail pointer in your linked list. Otherwise you don't need this corner case. If temp is equal to tail, we just want to set the tail pointer to previous pointer, then we will increment the temp pointer. So I will set tail equal to previous pointer, then I will increment temp equal to temp.next. Temp equal to temp points to memory address 300, temp.next, which is this null. So next time temp is going to point to null. So I have updated my tail pointer. Let's have tail pointer point to previous. This is only the case when we have a duplicate value at the end of the linked list. So next time temp is going to point to temp.next, which is null, temp equal to null. We will check while temp not equal to null. Yes, temp is null, and we exit out of the loop. This way we can once a temp equal points to null, this node is not referenced by any pointer. It is going to be eligible for garbage collection, and this node will be deleted from our linked list. This way we can delete all the duplicate values from a linked list data structure. Before implementing all these codes, we need to check whether our list is empty. If our list is empty, or if head points to null, head is equal to null, or if we have one node in our link, let's say we have only one node number 10, in that case there is no duplicate values and we cannot do anything. We just want to return. So let's jump to IDE and write code for this. First we are going to take care of the corner cases. I'm going to write a function public void delete duplicates. Inside this I'm gonna again check if is empty. If my list is empty, I cannot do anything, or if this.len equal to 1, this.len equal to 1, or if we have only one node in our linked list, or instead of this we can say if this.head.next equal to null. We just want to return. Else we maintain two pointers, node prev equal to null, then node temp equal to this.head. We loop over the linked list while temp not equal to null. Let's first define a hash set. Let's call it hash set. It stores integer values. Let's call it set equal to new hash set. We first check if temp.if set dot contains temp.data. We found duplicate. We want to delete it. Else we just want to add the temp.data in our set, and we just want to increment our pointers. Else we say set.add temp.data, and we set prev equal to temp and temp equal to temp.next. This way we increment our pointers. Once we found a duplicate value, what we are going to do, we are going to get rid of the duplicate value by setting prev.next equal to temp.next equal to temp.next. Then again we are going to check before incrementing our temp. We are going to check if the duplicate value is at the end of the linked list. If this dot temp equal to till, or this dot till, we just want to say this dot till equal to the previous pointer. I think that's it, and not this dot temp. No, only temp. If temp is equal to till, we set till equal to the previous pointer. Then we are going to, once we incremented the next pointer, the duplicate value will have no reference. The duplicate value will be deleted, so we are going to decrement the size of our linked list, len minus minus. Analyzing the space and time complexity of this algorithm, in case of time complexity, this takes constant time. This whole expression takes constant time. But once we reach the while loop, we are looping from the beginning of the linked list, and we go all the way up to the end of the linked list. So this while loop is going to take big O of n, or linear time complexity, where n is the number of nodes in the linked list data structure. Talking about space complexity, we have defined another data structure or set data structure. We store each element of the list, the distinct element of the list, to this set data structure. In the worst case scenario, if we have no duplicate value, we store all the distinct values in the set data structure. In the worst case scenario, it's going to have big O of n, space complexity, where n is the number of distinct values in the list data structure. I think that's it. Let's check our code. So I have 10, 20, 30, 40. Say I have a number 30 two times. So let's print our list. I have 30, 30. Let's remove the duplicate values. List dot delete duplicate. Was it delete duplicate? Delete duplicates. What was that? Delete public void, delete duplicates. Let's delete, sorry. Delete duplicates. Delete duplicates. Run our code. Number 30 is gone. Let's have a duplicate at the end of our linked list. 50 is gone. 50 is added two times. Say we have only one element in our linked list. I want to comment out all these lines of code. I have only number 10. Size is 1. We have number 10. Let's add number 10 two times. Control Z, Control D. 110 is removed, and I still have the size equal to 1. So this way we can delete duplicate values from a linked list data structure. Thank you guys for watching, and see you in the next video. Bye bye.